Okay, class, this is evaluating argument number 3 in your note handout. So we want to be able to build a truth table to determine whether this argument is valid in structure. And in order to do that, we first need to translate this argument into symbolic form, right? So what is the symbolic form of this argument? And in order to do that, we need to go ahead and assign some simple statements and with letters, and then we would go ahead and evaluate that, okay? So here we go. Every natural number is even, or it is greater than 0. Okay, so this one, we can deal with that first. Let's say greater than 0 being C, or is this. Okay, now how do we deal with every natural number is an even number? We have learned from previous lessons that every natural number is even can be translated as if it is a natural number, then it is even, and I'm going to call that B. A is a natural number, right? So the first premise can be translated as if a number is a natural number, then it is even, or it is greater than 0. Okay. Premise number 2 said number 7 is greater than 0. Greater than 0 is C. Therefore what? 7 is not even. Not even means not B. Okay, you might want to think, oh, you might be thinking, that sounds really dumb. I'm not sure what this is all about. And that is the reason why really we translate these things in symbolic form, so then we can forget the bias of the words and only evaluate the structure of the argument. What does that mean? The question would be, is it valid? Okay, is it valid? And what does valid mean? Valid means to look at the structure and think what the premise is lead to the conclusion. And maybe I should write this out in symbolic and in somewhat close to the symbolic form. We have two premises here, so we would say, does premise 1 couple with premise 2? Do they lead to our conclusion? Right? That's what it means to be valid. So we need to build a truth table for which statement? The statement that states premise 1 and premise 2 lead to the conclusion. So we need to build a truth table for A, then B, or C. Would that lead to our conclusion not B? Okay, so that is the statement that we need to build a truth table for. And then we would ask ourselves, after we build that truth table, is it a tautology? If it is, then the premises always lead to the conclusion. Then the argument is valid in form. Okay, so we can now go ahead and forget about the words. Just look at the structure of this argument, meaning let's go ahead and build a truth table for that. We have A, B, and C. Oh boy, that means we have 8 choices in terms of are truth values. So first, we say true, true, true. The first 4 would be true, and the last 4 would be false. Oh, I don't like writing too close, so let's skip a line. True, 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 and the last 4 will be false. False, 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 and false. Okay, so here are our choices so far. And then I'm going to go ahead and put true, 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 false, false, true, false, false, right? Our standard combination of 2 statements. And then I will repeat true, 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 false, false, true, and false, false. Okay, so that give us our choices. Okay, so now the next thing I would say is I am going to use order of connectives. So A in parentheses first, A imply B. And then outside of that, we say A imply B or C. And then go outside of that, I would say negation of B would be next. And then the entire statement would be last. A imply B or C. Would that lead to not B? And we want a tautology out of this compound statement here for it to be valid. Okay, so A imply B, that would be the first and the second column. True imply true is true. True imply true is true. True implies false, that is false. When the hypothesis happened, conclusion did not. The truth value of your conditional statement is false. Okay, and if the hypothesis is false, meaning the hypothesis did not happen, anything goes, your conditional statement is true. Okay, now we are looking at the fourth column and the third column, and the connective that we will look at is or. Okay, so we are saying true or true is true as long as there is one true in there. Our conditional statement is true. When it's both false, then our conditional statement is false. This is true, 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 and true. Okay, and then not B. B is the second column. Not B would be the opposite truth value of whatever B is. So first we have false, false, true, true, false, false, true, true. The opposite of column 2. All right. Lastly, we will go from this column here to this column here, and the reason why I list it that way, because then it's in order, right? True implies false is false. And as soon as you hit a false, do you even need to keep going further? No, because we know this is not a tautology. Therefore, our premises do not always lead to that conclusion. So this right here in structure is the argument is invalid. This argument here in structure is invalid. And if it's invalid, then it is not sound, because the first thing to be in sound is having a valid structure.